Okay, welcome back again as we continue with the interpretation. So now we go to the hydrogen NMR. So as I said earlier on, that this is the question, but I'm not so sure if you can be able to see. So this is the HNMR information. So we have three important peaks here. This one, which is a singlet, and we have these two that have been expanded here that are a doublet. But we also have this one which is appearing here. It's very slight, small, so I'll just consider it as a singlet as a benefit of doubt, but we'll see how it's gonna play in our results. Okay, so the expansion to this question, I'm going to show you the diagram for the expanded part so that you can see very clearly what's going on. So this is the expansion to that question. So we do have three important peaks, this one and these two, but that smaller one is this one which is appearing here. So we'll just consider it for the benefit of time. So normally when you are given this information for the hydrogen NMR, where do you start? So there's a table, a chart actually, that will help you interpret what type of hydrogens that you're dealing with. So I'm gonna take you to that chart. Take you to that chart. So you can find it in NMR as well. So this is the chart that you need to revisit. Okay, it's in NMR. So it will tell you in terms of the chemical shift values that normally shift values between probably I can say 6.8 going towards 8, right? They are aromatic carbons. Then if you have chemical values between 4.8 I would say to 6.8, they are phenylic hydrogens, those hydrogens that are attached to a double bond, not phenylic as such, but they are hydrogens attached to a double bond carbon. Okay, the phenylic hydrogens, it's this part, because you have a double bond carbon then attached to another carbon that is called hydrogen. So these are called phenylic hydrogens. So this is the chart that you need to take into account. So how do we use this chart to interpret our data? So here in this case, just check it's a carbon attached to hydrogens, and this Y, it can be oxygen, nitrogen, or a halogen. So in this case, the oxygen is out, a halogen is out, because we don't have a halogen in our formula, C9H10N2. So the only possibility is a nitrogen. So now coming to interpreting those that information on those three peaks on the HNMR. So we have that peak at which is about 3, which is a singlet. So it's this one, okay, which falls within that carbon that is bonded to a nitrogen. So this is the likely environment of that peak, and the peak is a singlet, which means there are no hydrogens on the neighboring carbon. Then we have a peak at about 6.6, right? And so the 6.6 peak is a doublet. So according to that chart that I showed you previously, this 6.6, it falls between this double bond carbon. So the hydrogens are attached to this carbon. They are the ones responsible for this peak. So now, a rule of thumb, values from 6.8, like we said, going closer to 8, they are aromatic hydrogens. So this is what you just need to know. So basically, this is how you interpret the information of HNMR. So the aromatic, the benzene ring, if you remember when we interpreted the degree of unsaturation, I suspected a benzene ring. So this is actually coming into shape. So we now have a benzene ring, we now have these double bonds, probably they are double bonds also of the benzene ring. Then here we have a carbon bond into a nitrogen, so we are yet to see what's going on with our structure. So now let's tune into the carbon NMR that will actually give us a clue on what really is happening. So stay tuned. So in terms of the multiplicity, there is nothing much. As you can see, this one is a singlet, doublet, singlet, and a doublet. So in terms of the neighboring hydrogens, here it's 1, no hydrogens, 1, no hydrogen. So to give us a clue of what is happening. So that's all for the HNMR. So stay tuned as we go to the carbon NMR. So the carbon NMR is going to give us a clue of how our structure should appear.